Hello guys and girls, in this video series we will be revising the 2019 Form 5 Mathematics Paper 3 final exam paper. If you are interested in getting some tips on how to tackle exam-like questions before you write your exam, stick with us while we reveal some of those tips, and you might as well get yourself that A which most students think is impossible when it's actually not, especially when you get us. So without any waste of time, let us start our revision. Alright, question 1. The table shows some terms of two sequences, R and T. A. Find the next two terms of sequence R with Roman figure 1. So here we are given a table of two sequences, sequence R and sequence T. On Roman figure 1, we are supposed to find the next two terms of sequence R. So with sequence R, we have 3, 5, 7, and 9. And what is required of us is to find the next two terms. In order for us to find the next two terms, the first thing we have to do is to determine what kind of a sequence is sequence R. Is it arithmetic, is it quadratic, or is it geometric? But first, let us test if the sequence is an arithmetic. One thing we know about arithmetic sequences is that they have a common difference. So let us test if we are going to get a common difference with sequence R. So 5 minus 3 is equal to 2. 7 minus 5 is equal to 2. 9 minus 7 is also equal to 2. So it seems we are getting a common difference. So what does that mean? It means this sequence is an arithmetic sequence. And with the common difference that we have, we are now going to be able to get the next two terms. We are going to use that common difference. So one thing we know is that from term number 1 to term number 2, we add the common difference. So that means also from term number 4, which is 9, to the next term, we also have to add a 2. So what is 9 plus 2? That is 11. And from term number 5, which is 11, we also have to add a 2. So what is 11 plus 2? It is a 13. So those are the next two terms of sequence R. Let us proceed to Roman figure number 2. Roman figure number 2, we are supposed to find the next two terms of sequence T. So with sequence T, we have 6, 9, 14, and 21. What is required of us is to find the next two terms. Again, in order for us to find the next two terms, we first have to determine what kind of a sequence is sequence T. Is it arithmetic? Is it geometric? Or is it quadratic? Let us first test if this is an arithmetic sequence. And with arithmetic sequence, we know that we are supposed to get a common difference. So 9 minus 6 is 3. 14 minus 9 is 5. 21 minus 14 is 7. It seems we're not getting a common difference. So that means it is not an arithmetic sequence. But we can still proceed from here and test if it's a quadratic sequence by checking if we are going to get a common difference with these terms. So 5 minus 3 is 2. 7 minus 5 is 2. So it seems now we are getting a common difference. That means this sequence is a quadratic sequence. So from here, how do we get the next two terms? Let us first focus on this sequence, or these differences. From here to here, we added 2. And also from here to here, we added 2. That means from this term to the next, we add a 2. So what is 7 plus 2? It's a 9. And also from here to the next term, we add a 2. So what is 9 plus 2? It's an 11. Let us get back to the main sequence. From the first term to the second term, we add a 3. And from the second term to the third term, we add a 5. So it's a 9 plus 5, which is equal to 14. So that means from term number 4 to term number 5, we are supposed to add a 9. So what is 21 plus 9? That is a 30. And what is 30 plus 11? 30 plus 11 is equal to a 41. So now these are the next two terms of the sequence T. So that is how you get the next two terms of a quadratic sequence. Now let us proceed to B. B says write the nth term expression for sequence R on Roman figure 1. So what do they mean when they say find, or when they say write the nth term expression? By that they say write the equation that determines the sequence. So how are we going to find the equation which determines sequence R? So when we were doing A, we found that sequence R has a common difference of 2. And we are going to use that common difference to find the nth term or the equation of sequence R. For arithmetic sequences, we have a certain equation that helps us get an equation for each and every arithmetic sequence. So that equation is Tn equal to a plus n minus 1 in brackets times d. So this is the equation that will help us get the equation of sequence R, or the equation of the arithmetic for the arithmetic sequence R, where A represents the first term. The first term of sequence R is 3. So let us substitute in the equation. Tn is equal to, the first term is 3 plus n minus 1. D is equal to 2. Tn is equal to 3, 2 times n, that is 2n, 2 times negative 1, that is negative 2. So Tn is equal to 3 minus 2, that is 1, plus 2n. So therefore our equation looks like this. It's actually the same thing. I just decided to start with the 2n and end with the positive 1. And that is just how we determine the equation of an arithmetic sequence. Let us proceed to Roman figure number 2. With Roman figure number 2, we are supposed to find the nth term expression for sequence T. And again, that means we have to find the equation that determines sequence T. When we were doing A, we found that sequence T is a quadratic sequence. So just like arithmetic sequences, we also have a formula that helps us get the nth expression or the equation of a quadratic sequence. and in this case that is Tn is equal to an squared plus bn plus c. So how do we get the value of a on b and c? To find the value of a, we use another equation, which is 2a is equal to the common difference, that is 2. So let us solve for a. We divide by 2. This cancels. A is equal to 1. And to find the value of b, we also have another equation, which is 3a plus b is equal to the first difference, which is 3. And we know the value of a. The value of a is equal to 1. So 3 times 1 plus b is equal to 3. Now let us solve for b. 3 times 1, that is 3, plus b is equal to 3. And now we have to make b the subject of the formula. We take 3. And now we have to make b the subject of the formula. This will cancel such that b is equal to 0. And to find the value of c, we also have another equation, which is a plus b plus c is equal to the first term, which is 6 in this case. We know the value of a, that is 1, b is 0, so plus 0, plus c equal to 6. So 1 plus 0 is 1, plus c equal to 6. To make c the subject of the formula, we will subtract 1, also subtract 1 here, and c is equal to 6 minus 1 is 5. Therefore, we will use these values that we found for a, b, and c to substitute in this equation. So Tn is equal to a is 1 n squared plus b, which is 0, n plus c, which is 5. Therefore, Tn is equal to n squared, 0 times n is 0, plus 5. So this is the equation that determines sequence R. In other words, that's the nth term for sequence R.